All right, so today we're going to look at 2.4, and that's on solving linear inequalities. So similar to what we did yesterday with solving equations, but we're going to look at inequalities. So instead of having an equal sign, you're going to replace the symbol with one of those four. Less than or equal to, greater than or equal to. So here's a couple examples of inequalities. The one on the left is just a true inequality. The one on the right could be true if you pick the right value for x. And there's more than one value. Right? If it was 3x equals 12, then there would only be one number. X would have to be 4. But in this case, the answer is anything bigger than 4. 5 would work, 6 would work, 13 would work. Right? Anything that's bigger than 4. So that's a big difference between solving an equation and solving an inequality. Inequalities generally have a lot of numbers that they could work for, where an equation, a lot of times if it's linear, has one answer. Sometimes quadratics have two. But these have lots of answers. So the way that we tell if a number is a solution is the same way we do it with an equation. You plug the number back in and see if you get a true statement. So let's say I wanted to check if 10 was a solution. I would fill 10 in right there. And if I fill in 10, 3 times 10 would give me how much? 30. And is 30 greater than 12? Yeah, so 10 is a solution. If I plug in 4, I get 3 times 4 is 12. Is 12 greater than 12? No. So in that case, 4 is not a solution because we didn't get a true statement. 12 is not bigger than 12. So any question on how you check if a number is a solution? Okay. So when we are talking about putting two inequalities together, there's two different words that we can put between them. Sometimes you see the word and. The other word you can see is or. It goes with the two. When you put the word and between two inequalities, that is a conjunction. Like that. A conjunction means between. Right? So this is basically saying between -1 and +3. Right? But you can't include -1 and you cannot include +3. So if we wanted to think of it on like a number line, here's 0, -1, +3. We would not include the wouldn't include the -1, wouldn't include the +3, and we would shade between. That's what this would look like. So the top is a graph, and the bottom one, this is an inequality. Any question on that? Now, when you have two inequalities with the word and, a lot of times they do shorten it up and they combine the two together. And this is what it looks like when you combine them together. This is still read the same way. When I read that, I start in the middle and I say x is greater than -1 and x is less than 3. Okay, so the way that you can combine it is you put the letter in the middle, smaller number on the left, bigger number on the right, and both inequality symbols point towards the smaller number. So as I said before, it's like a range. It's like a section of numbers between -1 and +3. So let's look at another one, just as an example of combining inequalities. Let's say I had x is greater than 5 and x is less than or equal to 16. If I wanted to combine those two together into one, where would the letter go? Yep, letter goes in the middle. Which number would go on the left? Yep, smaller on the left, and the bigger number?
16.
On the right. And both of the inequalities are going to point. When I say point, I think of making it into an arrow, so it's like pointing. Both inequalities are going to point towards which number? They're both going to point towards the 5. There's your first one. And this time, the second one, it's less than or equal. So if you wanted to think of it on a number line, here's 5, here's 16. We'd have an open circle on 5, and we'd put a closed circle on the 16. Okay, if you're not familiar with open and closed circle, we'll talk about them. I think we have talked about them at some point. Okay. So any question on taking an inequality and combining it? And if you wanted to split it again, well, there's one of them. And there's the other one. Okay, in the purple box, it's x is greater than 5. That's the first one. And then in the blue box, x is less than or equal to 16. So sometimes you want to take one that's combined and split it into 2, or take one that's 2 and combine it into 1.
If we were taking a test, would you mark it wrong for left and 2?
Would I mark it wrong for what?
If we didn't combine the equations.
So you wrote like the top one instead of the bottom one? It just depends if it says to combine. If it said combine the two inequalities into one, and you didn't, I mean, I'd give you some points because you got this far, but you didn't do the final step, which was to combine them. If the question didn't specify, then you could leave it either way. Yeah. All right. So all these problems we've done, even that one over there, that's an interval of numbers between 5 and 16. So we're going to talk about some different terms to describe intervals. We're going to use the terms open and closed, and we're going to use the terms bounded and unbounded. The first one that I gave you, that I circled in red, that is an example of what we call an open interval. Okay, so let's look at the different kinds of intervals that we can have. Okay, first types of intervals we're going to talk about are what we call bounded. Okay, bounded means that the endpoints of the interval are numbers. Okay, they do not go on forever. What symbol do you think you would see in a problem if the interval went on forever? Like there was no highest number you could pick? Yeah, you'd see an infinity. That would be like if I said to you, you have to pick a number greater than 3. That's unbounded. Right? Greater than 3, what's the limit? What's the highest number? I didn't give you a highest number. I just said you can pick anything greater than 3. Bounded would be, all right, pick a number between 5 and 10, right? Telling you can't go below a certain point and you can't go above a certain point. Okay, so the actual numbers that you start and stop at, they're limits, and you can't go past them. Versus infinity, that goes on forever. Okay, so the different types of bounded intervals we can have an interval that is completely closed. Closed means that you can include each endpoint. So if I was going to graph this one, it would look something like this. Circle on A, circle on B, both closed circles, and shade between. Okay, all of these are going to be shading between for bounded intervals. But it's just whether or not you include the left and the right. The next type of bounded interval is an open interval. That means you can pick any number between A and B, but you can't actually pick the A or the B. That's an open circle. Okay, so the top one, fully closed. Bottom one, fully open. But I said there's 4 types. So what else do you think can happen?
One's closed, one's open.
Yeah, one's closed, one's open. That's exactly what this kind of interval is right here. One's closed, one's open. And if you forget which one is closed and open, think of it if you were drawing circles. Would it be a filled-in circle? That's closed. Or would it be an empty circle? That's open. So you could have an interval that's open on the left, or just open on the right. So this one is closed on the left, open on the right. So that would mean you could pick a number between A and B. You can include A in the numbers you pick. You cannot include B. Okay, and the last one. Again, you're picking numbers between A and B, but this time you're not allowed to choose A, but you can choose B. So whenever we have a circle that's filled in, the symbol that you'll see when you write it as an interval is a bracket. Okay? Open and closed circles are only used when you draw graphs, when you draw pictures. If we're going to write them like we have on the left, we use brackets and parentheses. So bracket is what you use for a closed circle. Parentheses is what you use for an open circle. So let's go back up to this one. If I was going to write this in what we call interval notation, the lowest number I can pick is -1. The highest number I can pick is 3. Can I include the -1? No. Can I include the 3? No. That is not a coordinate. That represents all numbers between -1 and 3, not including either endpoint. If we look at this one, what's the lowest number that you could pick for this one on the right? 5. What's the highest number? 16. Can you include the 5?
No.
No. Can you include the 16?
Yes.
Yes. That's how you would write this one as an interval. Okay, so it's 3 different ways to write your answer. These 2 are both inequalities. This is a graph. This is an interval. Okay. It's also called a set or an interval. A set is just a group of numbers. That's all. Okay, and I already drew all the examples for you right on the right-hand side. Okay, so we can have bounded intervals, and then what other kind of interval do you think we can have besides something that's bounded? We can have unbounded. So we know it's unbounded if you see an infinity symbol. Okay. This is the kind of graph that if you did it, it would have an arrow on it. So for this one on the upper right, I can include 5. That's the lowest. And the highest value you can pick is infinity. That means it looks like this. It just keeps going. So an unbounded interval is not a between 2 numbers kind of thing. It's a from one number on to infinity, or from a number to negative infinity. Sometimes you can include the number, or like in this bottom one, you would not include the number. Okay, and the 2 on the left would just be pointing, these 2, the arrows would be pointing to the left. Okay, but whenever you write an interval, make sure that the lowest value always comes first, and the high value always comes second. kind of like you're telling me start at 5, stop at infinity, which goes on forever. Any questions on that? Bounded versus unbounded. Okay, so those are the different terms that I'll use. So you might hear me read off answers in the homework, like the closed interval from 2 to 6. That would mean something like this. You can choose the 2 and you can choose the 6. Or the open interval from 1 to 10. That means 1 to 10, not including 1, not including 10. So now let's just practice translating between the different notations. Okay, so yeah, this is set or interval notation. I want to translate that into an inequality. Okay. So when I write this as an inequality, I need a variable. Can use any letter. But what letter have we been using?
X.
Yep, so we're going to start with an X. Where's the -3 going to go? It's going to go on the left. What about the 5?
On the right.
It's going to go on the right. And both of my inequality symbols are going to point towards which number? They're going to point towards the -3. For the one that I put first, is it going to have the equal to?
No.
No. Okay, because that's a parenthesis. Parenthesis means open interval, which means you don't include. How about the second symbol?
Yes.
Yes. That means you do include. Now, since this says write as an inequality, you could do it like that. Or if you did this, x is greater than -3, and x is less than or equal to 5. It's a little bit longer, but that would also be correct in this case. Most of the time, if it says to do this, I'm probably going to go with the short way, not the long way. Okay. Any question on that one? All right, let's try this one. First, actually, is this interval bounded or unbounded? That's bounded. I'm telling you a low number and a high number, and you got to pick numbers in between. How about this one? Bounded or unbounded? It's unbounded. There's no limit how high of a number you can pick. Will infinity always be in a parenthesis? No, I could give you one without an infinity like that one.
No, I mean, if you see an infinity, will it always have a parenthesis?
Oh, yes. Yes, parenthesis will always have an infinity because if you put a bracket on infinity, bracket means you can reach that number. We can't ever reach infinity. Okay? We can reach -4, that's fine. But no, you can never reach infinity. So any infinity symbol will always have a parenthesis on it. Yep. Okay, so first thing we do is we start with our letter. Okay, what are we going to use for our letter this time? Yep, we'll use X. And what kind of numbers are we allowed to pick based on this set that they describe?
-4 higher.
Anything that's -4 and higher. So how would you write that as an inequality?
X is equal to, X is greater than or equal to -4.
Yeah, that's all you need. When it's an unbounded interval, it's actually simpler to write. Some people have said something like, well, you put the smaller number on the left, you put the bigger one on the right, and then you put your symbols. Well, that's technically okay, but you're telling me x is less than infinity. What number isn't less than infinity? Nothing. There's no number that is less than infinity. So, I mean, there's no number that's bigger than infinity. So you don't have to say that. I know that x is less than infinity. Everything is. So you have to say the first part. X is greater than or equal to -4. That's all you need. Okay. How about this interval? Bounded or unbounded? Bounded. Open or closed? It's a closed interval that is bounded. Yep. Okay. And how would we write that one as an inequality?
-8 is less than x, and then -3 is greater than x.
Okay, so you're gonna write it as two separate ones, and
Well, I was trying to combine them, I just couldn't figure out how to say it.
okay, so you wanna combine them?
Yeah.
Okay, so -8 is less than x, and what would be your next symbol?
X is less than -3.
Wouldn't it be less than or equal to?
Right, we gotta put those equal to's under it. How come?
Oh, because it's close.
Because we have the brackets. Yep. And that is correct. Yep. -8 is less than or equal to x, which is less than or equal to 3. So does that mean you include the -8 and the -3, or you don't include it? You include it. Yep. So again, this is called a set or interval notation. This is called an inequality. So now, let's look at changing an inequality to a graph. Okay, so on the test, you'd already have a number line set up. And what kind of circle do we need on the 2 this time?
Closed.
Closed. And we're shading all numbers greater than or equal to 2, so that heads to the
Right.
to the right. Yep. And is this bounded or unbounded? Unbounded. Never stops. Okay, so that's an unbounded interval. Always has an arrow when you do the graph. All right, let's do this one. X is less than 5. So let's do, set up our number line. What kind of circle do we need this time? Open on which number?
5.
Open on 5. And this time, how do I shade?
Left.
Yeah, shade to the left. Everything's smaller than 5. Okay, so the way this will work when you do it on pair assessment, there'll be like, for this question, probably 4 different tools to pick from. One of them will look like that, that, and something like that. So all you have to do is click on the tool that you want. So in this case, you'd be clicking on this one, and you just drag it down to the number 5, and then it'll automatically shade it. And if you make a mistake and you drag it to the wrong spot, I think you can take the open circle and slide it to whatever number you want to put it on. Okay, any question on that? Let's do one more of these. So again, converting an inequality into a graph. Okay, how many circles am I going to need when I do this one? I'm going to need 2. What kind of circle on the -1?
Closed.
Yep, so that's closed. What kind of circle on the 3?
Open.
That's an open. And where do we shade? In between. So is this a bounded or an unbounded interval?
Bounded.
This one's bounded, yep. Fully open, fully closed, or half open?
Half open.
It's half open, yep, half open on the right. So this is an inequality, this is a graph. Okay, so we've looked at kind of 3 different ways now: inequalities, graphs, and then the set notation with the brackets and parentheses. So now, when we solve inequalities, we're going to use exactly the same steps as when we solve equations. But there is one trick. If you multiply or divide by a negative, you have to remember to do something. Yep, you got to remember to flip the sign of the inequality. Okay, and again, it's only if you multiply or divide by a negative. You never do it when you're adding. You never do it when you're subtracting. Now, there is one other time we might flip the sign, but it has nothing to do with multiplying or dividing by a negative. If we had an answer like that, a lot of times when we write our inequality, they like the letter to be on the left side and the number to be on the right. So they like the format to be letter, then a symbol, then a number, okay, in that order. That's not in the order letter, symbol, number. If I want to put it in that order, I can do that, but I have to remember it was pointing at the 3, and that's what it would look like when I rewrite it. Okay, so that's just a rewrite. That's not actually multiplying or dividing by a negative. Any question why I flipped the sign here? Okay, so that's the only other time you might flip the sign if you don't like the format of your answer. But that's different. Okay. All right, so let's see if we can solve this one. What would be the first step on the left side?
Distribute.
Yep, you're going to distribute that out. And what do you get when you distribute?
3x negative 3.
3x minus 3. Okay, so that's a good first step. Still something else I need to do before I start moving things from side to side.
Not like term.
Yep, and what are my like terms?
Negative 3 and 2.
Yep, so we'll combine those. And negative 3 and 2 gives me negative 1. All right. What would we do next? Minus what?
Minus 3.
Yep, we could minus 3x on both sides. So that takes care of that. And we could do something else at the same time.
Subtract 6 from this one.
Yeah, if we're going to put all the x's on the right, then let's put everything without an x on the other side. So now that's gone. What does that leave me with on the left side?
Negative 7.
Negative 7 is less than or equal to 2x. Okay, and my last step? Yep. Divide by 2. And now if they don't care what letter you leave, where you leave the letter in the final answer, you could leave it like this. That's okay. Or if you wanted the variable on the left side, there's your x. And what direction should the symbol be pointing?
Towards 7, 2.
Towards the negative 7 over 2. Those are exactly the same thing. Didn't flip it because I divided by a negative. I never divided by a negative in the whole problem. I flipped it at the end because I didn't like the format of the answer. Okay, I usually try to do letter, symbol, number. Okay. Any questions on that one? All right, so let's look at, we have that, and then okay. So let's look at how we can solve an inequality on the calculator. Most of the ones that we've done so far, I would say they're pretty straightforward. You wouldn't need the calculator, but we might do some that are a little more complicated, and then we do. So to solve on the calculator, there are two methods. One method is to get the inequality with a 0 on one side. Kind of like getting an equation equal to 0. Get 0 on one side. And then we're going to use the root or 0 feature. Okay. And then depending on what the question asks, the answer is either going to be everything above the 0 you just calculated, or it could be everything below, either above or below. Whether or not they want the positives or the negatives, it depends on the question. Did it have a less than 0 in the question, or did it have a greater than 0? Greater than 0 is positive. Less than 0 is negative. Okay, so let's try an inequality, and we'll use this method. Now, normally, this is an inequality I would bother with the calculator. Because it's easy enough, if you want to solve it by hand, we just add 1 and divide by 4. So if you add the 1, you get 3, and divide each side by 4, you're done. X is less than 3/4. But now I want to do it on the calculator and see if we can get the same answer. Or X is less than, it's going to give you a decimal on the calculator, so 3/4 is the same as what? 0.75. Okay, so the method says get 0 on one side of the inequality. Okay, so let's take this. And how would I get 0 on one side?
Minus 2.
Yep, minus the 2. Now, put that in y1. 4x minus 3. And we're going to be looking for one of two things. We're either going to be looking for where 4x minus 3 is above 0 or where it's below 0. In this case, we're looking for where it is below 0. Yeah.
4x minus 3 or 4x minus 3?
4x minus 3. Yeah. Okay, so let's do zoom 6. At some point, this line is exactly 0. So we're going to calculate where it's exactly 0. And then we want to get all the values that are going to be under the x-axis. That's what this means. Less than 0 means tell me where it's under the x-axis. So we'll do second calc. Option 2. I think, have we done option 2 before? Calculate 0? Yeah. So pick a point left, right, and do your guess. Okay, so let me put this down here. Okay, so now we know where it's exactly 0. It's at 0.75. The original problem wants to know where it is under the x-axis. If I want to be on this part of the line, which is what they tell me, under the x-axis, would I pick values that are bigger than 0.75 or smaller?
Smaller.
Right, smaller. Because if I keep going to the left on the x-axis, my line is dropping down further and further. If I go to the right of 0.75, like let's say I go to 1, I'm going to be up here. That's not less than 0. That's above 0. Okay, we want to be under. So we have to pick values that are smaller than our 0.75. If the question said, where is it greater than 0? Then I would have wanted values above the x-axis. But in this case, it's below. Okay, so any question on using the method where you get 0 on one side? Okay. Second method is we don't get 0 on one side. We leave the problem just the way they give it to us. Okay, so we'll do the same one again. But this time, you're going to take and put what's on the left in y1 and put what's on the right in y2. So this has the advantage you do not have to rearrange it to get 0 on one side, but now you have to type in two separate things. Okay. So 4x minus 1 and 2. Okay. So we'll put that in. And then we're going to calculate where they cross. Let's hit graph. There's the 4x minus 1, and there's the 2. So the 4x minus 1, I did that in blue. Just keep that straight. And I did that one in red. Let's put this over here. That's not it. That's fine. Let's put it down there. So now I need to calculate the intersect. Well, I didn't do that. So second calc, option 5, because there's only 2 lines and they only cross in one spot, pretty much just hit enter 3 times. Okay. So now I've got my intersect. And notice it's exactly the same as the root. All right, so now the question is, do you want to be above one line or do you want to be below the other line? In this case, we want the blue line to be under the red line. That's what that means. Where is the blue one? Below the red one. That happens in this section right here. That's where the blue is under the red. Okay, if I want to be on this section, would I pick values that are larger than 0.75 or smaller? Smaller, yeah. If I pick a value larger than 0.75, I would be here on the red line, and I'd be like up here on the blue line. That's not what I wanted. I wanted the blue one under the red one. So as long as I pick values that go that way, from that point, there's a value on the red, and then it would be like way down there on the blue. So anything less than 0.75. So there's two different ways to do the same question. Calculating a root or calculating an intersect. Method 1, method 2. Doesn't matter which way you do it. Okay. Any question on either method? Okay. So we've already kind of looked at double inequalities a little bit. That's where you have an x in the middle, and then something on the left and something on the right. And the easiest way to solve this problem is to split it back up into 2. So I told you earlier, sometimes you might need to take something and split it. This is where you need to do that. Here's your first problem, and here is your second. So write down the first one, put down the word and then write down the second one. And to solve each one of them, how do you do it? It's going to be the same step for both.
Divide by 2.
Yeah, divide by 2. Divide by 2. So you get x is greater than -4. And what do you get when you solve the one on the right?
X is less than 6.
X is less than 6. That's how you solve a compound or double inequality.
And then you put them back together? Or
You could leave the final answer like that, or you could put it back together. It didn't say to, so in this one I'm not going to. But you could put it back together. And if you're wondering, well, why don't you just solve it the way it is and just divide by 2, divide by 2, and divide by 2 instead of splitting it? That would work for this one. The problem is going to be if you end up with x's here and over here, or if you end up with x's in all 3 spots. In this case, that's a little bit more complicated of an inequality. You can't just say, oh, divide everything by 2, and then you get the x by itself in the middle. You're not going to be able to get the x by itself in the middle here. So the easiest way to solve that is split it into 2 problems and solve each one separately. So let's try this one. Okay. When I split that into 2, what would be my first inequality?
negative 3 is less than 2x plus 5 over 3.
2x plus 5 over 3. And my second one?
2x plus 5 over 3 is less than or equal to 5.
Okay. And now the steps are exactly the same on both. What would be your first step?
Multiply by 3.
Yep, you're going to multiply both sides by 3. That's just going to get rid of the denominator of 3. So negative 9 is less than 2x plus 5. And you're going to do the same thing here too. Multiply both sides by 3. So I'll just do both at once.
You're multiplying by cubing,
What's that?
right? You're multiplying, not cubing it, right?
Correct. Yeah, this is just times 3. Yeah, it looks that's in a bad spot. So yeah, I shouldn't put that there. I'll just put times 3. That one I don't have space. But yeah, you're just multiplying it by 3. Times 3. Okay. And now what would be your next step on both?
Subtract 5.
Yep. So minus 5, minus 5. That's gone. Minus 5, minus 5, and that's gone. Negative 9 minus 5 gives you negative 14. And 15 minus 5 gives you 10. And last step on both.
Divide by 2.
Divide by 2. That's gone. That's gone. And we get negative 14 divided by 2 is negative 7. So x is greater than negative 7. And x is less than or equal to
Negative 10. Oh, sorry, that's not negative. 5. Sorry. Just
5. There you go. So that's how you solve a double or compound inequality. Any questions on that? So the way that we split that up is very similar to what we're going to have to do here. We're going to also use that approach of splitting into two problems to solve when we have an absolute value. So we did this yesterday with equations, and it's pretty much the same steps. Very first thing you have to do is make sure that the absolute value is isolated. Okay? That means there's no numbers on the outside of the absolute value bars on the left side. Okay? If I'm not going to do this one, but if I did, is the absolute value isolated?
Yeah.
Yeah. Okay, so once it's isolated, then we're going to split it into two problems. The first one is exactly the same as what we did yesterday. Copy down the original problem, just take out the bars. Okay, that's the whole reason why we're splitting it. We gotta get rid of the bars. So the first one, copy it and take out the bars. Now the second one, yesterday we copied it, we took out the bars, but we had to do one extra thing.
Negative.
What did we have to make a negative?
The thing on the other side.
Right, we had to make the number on the other side a negative, and we're going to have to do one more thing because we made that number negative.
Flip the sign.
We have to flip the sign. Yep. So for the second inequality, you copy down the original without the bars. You're still making the number on the other side the opposite, but that's the new part. We have to flip the sign. So that gives us our two inequalities that we're going to solve. Now, whenever you write two inequalities, you've got to put a word between them. What are the two choices I said you have for words?
And or.
Yes, you could put an and, or you could put an or. But you can't just randomly pick. Okay, you have to make sure you put the right word between them. And the word, what's going to go between them, is going to depend on what was in the original problem. So in the original problem, you look at that symbol. That symbol tells you if if you're going to do an and or you're going to put an or. If the original problem has a less than or equal to, we're going to use the word and. If the original problem has a greater than or equal to, we use an or. And the way I remember it is if you pronounce this, instead of saying greater, if you pronounce it as greater is an or. So greater or equal is an or. Less than is an and. Okay, so just remember the greater symbol is an or. All right, let's try one of those. Before we even split it, we can already tell, is this problem an and or an or? And it's an and, because it's a less than. Less than is an and. So if I want, I could put that down right now. And. Is the absolute value already isolated?
Yes.
Yep. Then we can split it into two problems. What would be the first problem I split this into? X minus 3 is less than 3. And what would be the second problem? Yep, perfect. Flip the sign and made the other number negative. Okay, to solve the one on the left, how do we get the x by itself?
Add 3.
Add 3. Add 3. And we get x is less than 6. And how do we solve the one on the right? Add 3, same steps. And for this one, we're going to get x is greater than 0. So I'm basically saying you can pick a number between 0 and 6, but not 0 and not 6. Oh, they want a graph. Okay, so let's do the graph. What kind of circle on 6? Open. What kind of circle on 0? Open. And where do we shade? In between. Question on that one? Well, I don't want to solve that, but what would it be, an and or an or? Which one?
Or.
This is an or, because that's a greater symbol. Greater is an or. How about that one? If you were going to solve and or an or, that's an and, less than. You just split it into 2 and solve it. Okay, we'll finish up with this one. Yes?
If we have to solve it, and it says use the calculator, does it have to be in decimal form? Or like, if it's something we can do in our head, can we just put it in like fraction?
Yeah, you could, because even though that says to use the graphing calculator, I mean, you could just split it and solve it.
Okay.
You don't have to, because that's not one that's too complicated.
Alright, so it's fine if it's in fraction form.
Yeah.
Alright.
Yep. Does anybody want to see me type in something like that on the calculator?
My question is, what if this was what if it was flipped? How would that affect the and and
That symbol?
or? No, what if it was 4 that it was greater than?
Right, so like if this symbol was just flipped.
Yeah.
Well, the quickest way to see it is just looking at a picture. Math number, absolute value. So we're going to get, an absolute value is always a V shape. That's what it looks like. Looks like a V shape. And 4 is going to be a horizontal line. So I'm either looking where I'm above or I'm below the horizontal line. If it was an and, you would be looking for the section in here. It would be, like, I can't estimate it perfect, but it would be somewhere between like 2.5 and negative 1.5. That would be if it was an and that's what it is right now.
But what if the whole equation was flipped?
Right, so if this was an or, then you would be picking a number from here or higher. So like, let's say x is greater than 2.5, or x could be smaller than negative 1.5. So it would be everything out this way and everything out that way. That's the answer if it was an or. So you're either looking for where you're above the red line or below the red line. If you want to know where you're below the red line, then you have to stay between those two x values. You've got to stay in the middle of them. If you want to know where you're above the red line, then you have to be outside those two x values, going in opposite directions.
What I'm asking is, what if the absolute value wasn't on the left?
She's saying, like, what if it was 4 is greater than absolute value of 4 minus 2x?
Yeah, that's what I just did.
Yeah.
It's that it doesn't matter, like, if this problem is exactly identical to this problem. There's no difference between the two. Yeah, that's just how you write it kind of thing, but they mean exactly the same thing. Yeah. But I thought you meant if you just flip that side. Yeah. All right, let's look at this one. It's our last one. Solve algebraically. And they want to know where we can divide these two things and get an answer greater than 0. Well, what kind of division problem would you have to do to get an answer that's positive?
By itself, right?
If you divide something by itself, you always get 1. But in general, what kind of numbers can you divide and it will always come out positive? A negative divided by a what? A negative. That kind of calculation will always come out positive. What else? You could also divide a positive by a positive. Those are the only two ways that you can ever do division and get an answer that's bigger than 0. You either divide 2 negatives or you divide 2 positives. One of these is impossible in this situation. Which one of these doesn't make sense?
Negative.
Yeah, why would this be impossible?
The absolute value.
Right, the bottom is never going to be a negative. So the only way that this problem could ever come out bigger than 0 is the top has to be positive and the bottom has to be positive. Well, when is the bottom positive?
Always.
Always. So I don't have to worry about the bottom. I just have to worry about the top. If you can figure out when the top is positive, then the bottom is always positive, and a positive divided by a positive is always bigger than 0. So we just have to know when the top is positive. What kind of numbers could you pick that would make the top positive?
Anything greater than negative 2.
Anything greater than
Negative 2.
-3.
Oh, is 0 considered a positive?
No, because it's not equal to or, right? It's not equal.
No, 0 is not a positive.
Yeah, so if you put in,
Like -2.5.
oh, I see what I was wrong.
Yeah, so you could plug in like -2.5, that's okay, negative 2.9, but you can't go to -3. Right? So if you pick any number that's greater than -3, that will make the top positive. The bottom is already positive, and a positive divided by a positive is always bigger than 0. And that's it. That's how you solve that one. So when you have a division one like that, you just have to reason through this and figure out which one of the two cases it could be. And then go from there. Okay. Question on that? Okay, so that's homework for tonight. Again, it's a lot of individual questions, so just make sure you copy that down. Tomorrow we'll do our last section for the week, and then Thursday, that is a review.